Hello and welcome back. Today we're going to start talking about background workers and background worker hosts and how they apply to Azure Cloud Services. Let's take a peek under the hood on how AzStudio's architecture looks. So the first piece we'd like to look at is the Azure Cloud Service, our worker. This worker can be thought of as an empty shell that holds the core AzStudio libraries and knows what environment it's actually executing in, but it does nothing else. It's waiting for some plugins. For each worker, there's going to be a mapped storage container, a shortcut name essentially, in our system. In the storage container, you drop your plugins and any libraries that those plugins depend upon. When the worker service starts, it will query the storage container and see what files it has in it. Those files will be loaded into the temporary directory in the worker host service. Then anything that's a plugin will be loaded into memory and initialized. Once initialized, the container will run each plugin in sequence once per second, unless all plugins report that they have not done any work that sequence, in which case the container will slow down, adding a second between its execution cycles. Now, the thing to keep in mind, the reason we do this is because all services go through a low consumption periods and high consumption periods. When you're in a high consumption period, these plugins should be executing at the maximum possible speed. But when you're in a low consumption period, you want your workers to throttle down so they don't consume Azure resources. Remember, you're being charged on a per use, per consumption basis in Azure. So if you have this kind of logic built into your container, you can save a lot of money. Another advantage we have of this system is that the worker can be deployed once, but the containers can be updated continuously. The programmers don't have to worry about the mechanics of the Azure Cloud Service. They only have to worry about implementing a plugin interface, which is quite simple. Additionally, because the workers are separated from the container, we can load them in other containers that aren't cloud-based and test them and debug. AzStudio has just such a container, which will allow you to exercise your plugin code in the different environments that you would want to deploy to and ensure that they work in every environment before you actually load them into the cloud. An additional feature is that we have a table storage link that wraps into the Azure Cloud Service. As the Cloud Service executes the plugins, it can query it for status and then write that status in real time to the table storage. Since you have a table store data source, you can now attach analytics, reporting, and alerts to the plugins without knowing how they're hosted or what environment they're hosted ahead of time. Because of this abstraction, the worker doesn't have to know about where it's going to report its status to. It just implements a simple interface. The container can make sure that the table store is updated regularly. And any other analytics or messaging that you would like to be driven off this table is also abstracted away. You could have multiple services in your architecture reporting to one table so that you can have unified status of all your background workers in all environments. This design helps you manage your Azure and cloud resources very granularly. Since each worker is its own work unit and each worker can exist in any container, if you have many workers that do only a small amount of work daily, you can cluster them into one container and one worker. If, however, a worker starts to use too much resources or doesn't get executed in a timely fashion, you can move it into a different storage container and map another cloud service to execute it. This allows you to mix and match what kind of workers you'll have running at any given point in time. It's also very easy to see where your workers are contained, and it's also easy to get unified reporting out of those workers with almost no work. So basically you get a scalable architecture, a pre-built host, and the basis for all your analytics and reporting included in the AzStudio APIs. So, now that we've looked at the architecture, let's look at the container or the host worker that we're going to use. The worker host project is already written, and it's in your sandbox code workers host folder. Before we get into the code itself, let's look a little bit at the configuration. The first thing we're going to be doing is looking at what we actually have to configure in this system. There's only two things you need to configure, which is the CAS token and the CAS key that the other products that we've shown you need. This is going to determine which environment your worker host is actually residing in. From this point forward, you'll be bound to the AzStudio configuration services, and your plugins will be able to access all of the shortcuts that you've created, just like any other piece of code in our architecture. Okay, so you've configured the system. Well, almost. We have a few more pieces of information we'd like to put in as just constant. So, something to note about this project is that there's only one actual C# file. It's actually very lightweight and small. The worker host is a container. It doesn't really contain any of your business logic. Its primary duty is to make sure that all the plugins execute and that they report their status to the right place. And it also functions as a libraries host. It has the AzStudio Common library inside it and the Azure libraries that it supports. This does mean there's one consideration when building your plugins and your host. They must agree on the minimum version of AzStudio Common that will be consumed during runtime. If your host AzStudio Common package comes out of date with your plugins, you'll need to update your host and redeploy. This is a very infrequent occurrence, though, and should not really impact your operations or really your development team's work. At least no more so than Microsoft's updating of their API libraries, which you're going to have to keep up with in any case. Alright, so there's only a few constants that are actually in the file. One is a role name template so that we can report out to the logging and status what role host is actually running at this point in time. We also want to know what the shortcut name is to the container that has the workers or the plugins in them. We also want to know what table shortcut we should use to report out status, and what the partition key you'd like to use when writing out status. For those of you who are familiar with table storage, the row key will be the plugin name itself. So, looking at the code, when the package starts up, we're going to actually go and look at the blob container. We're going to load in the plugins. We're going to report that out to the log, and then we're going to wait for the execute method to be called. Once the execute or run command is actually called, it launches this threaded async task, which is where the code is actually looping. Now this code will loop until the package or the role instance is terminated. As it loops, it's going to do just a few basic things. It's going to go through each plugin and ask for it to execute. Now your plugins will return whether or not it performed work this cycle. That's important because if all the plugins report that they have not done work this cycle, we will increase the sleep time between loops to a maximum. This allows all workers deployed in this manner to respond to workload. If workload goes away and stays away for some period of time, the workers will stop spinning up and using Azure resources. They'll get slower and slower. But as soon as work is detected on any of the inbound data sources, queues, databases, tables, blobs, whatever you have, then this cycle will immediately speed up to its maximum speed. This is your first tier of dynamic scaling. It's the most primitive tier of dynamic scaling, but it is very effective. It can save you thousands of dollars a month if you have a lot of plugins deployed. Deployment of this worker host is pretty much the same you do anything else. You can generate a package manually or in automation, and you can take that package and deploy it to your cloud service host the normal way you would do so, either in an automated or manual fashion. The nice thing is that this package will almost never need to be redeployed unless there's a major update to the APIs. We'd recommend you spend a few minutes playing with this code, looking at it carefully, seeing how it operates, and understanding the worker host role. Because this is a sandbox and the worker host is fairly locked down, you cannot deploy this host in this environment. However, if you have your own Azure subscription, you can create a classic cloud service container, and you can create the package here and deploy that package to the container. The nice thing is that will actually connect to all the AzStudio sandbox resources that you've got configured in the sandbox. And this is a really neat way to show that multi-environment, even mixed hybrid environment deployment of background workers is quite possible. Actually, Anything that uses the AzStudio configuration provider can be deployed in any data center, anywhere you like, and it will self-discover the resources it needs to connect to, no matter where you've actually exposed them. Now that's a really advanced topic, and probably not something you're wanting to try out today, but it's something to keep in mind as you examine this code and examine the host. In our next video, we'll cover building the plugin, testing it, and deploying it. Thanks for watching.